I'm Anil Kumar. Let me thank my subscribers for active participation and sharing some excellent questions. Now this one, my subscriber wants to understand the combination of functions. In part 1, we discussed these two functions and we had sketched and found domain range for their sum and difference. In this part, we'll consider product and quotient of the given functions. Functions given to us are f of x equals to square root of 3 minus x and g of x is equal to square root of x square minus 1. To begin with, let me make a table of values for both these functions, right? So let's put some values here. That should always help. And it will help us to find their product and sum. So let us say these are some x values and we'll write f of x and g of x. Now as you can see, for the given functions, let's say 3 minus x, the domain is less than equal to 3. And for the other function, x square minus 1, domain is either greater than 1 or less than 1. So common values for these two functions are between 1 and 3 on the right side. So let me write down x values as 1, 2, and 3. On the left side, we'll consider minus 1, right? And then we can consider minus 2, right? So these are good values to check which are common between these two domains. As you know, combination is always done on common domain. So that is the idea, right? So you can use your calculator, calculate these values. So I'll just substitute some values here, which we calculated in previous also video. So if I write 3 for f of x, x3, it gets me 0. If I write 2, 3 minus 2 is 1, square root of 1 is 1. And if I write 1, I get square root of 3, right? So we could write square root of 3, which is 1.7. If I write minus 1, then we get square root of 4, which is 2. And for minus 2, we get square root of 5, right? So let me write square root of 5. As far as g of x is concerned, 1 and minus 1 will give us 0, right? If I write 2, 2 square is 4, 4 minus 1, we get square root of 3. And for 3, 9 minus 1, 8. On this side, you see this is an even function. It is symmetric about y-axis. So minus 1, 1, 2 minus 2, these values will match, right? So let me just write 3. Correct. So minus 2 square is 4, 4 minus 1 is 3, square root 3. So that is what we get. Now based on this, we can always sketch both these functions, right? So we'll just make a sketch of these functions here, side by side this time. So let me just sketch them here. Okay. So the first function, which is square root of 3 minus x, is going to be kind of like this. And the other function, which is g of x, which is square root of x squared minus 1, will be kind of like this, right? Okay, so let me put some values there. This is at 3, this is minus 1, this is 1. And what we really considered here is that at 3, this value is square root of 8. This is important since 3 is our boundary for combination of the functions. These diagrams are not to the scale, okay? So that is how it is. And what we found is that minus 1, this value is critical. The function's value is 2 here. And at 1, the value of this function is, if I write 1, I get square root of 2. I got it wrong. So if I write 1 here, 3 minus 1 is 2. So this is square root of 2, not 3. Okay. So this value at 1 is square root of 2. Okay. So these are two critical values. So I'm just putting a point there. Fine. Now let's look into the product and quotient of these functions. Okay. So from these values, we can always calculate the rest of the values. We'll again we'll again continue with this table here. And this time, what we are going to do is we are going to fill the values for their product and their quotient, and then we will sketch them, right? That is kind of easier to do. So we'll take some x values and write the product of these two and also what is f of divided by g. This is a faster way of working, right? As we know, these operations can only be done on common domain. So the common domain is -2, -1, 1, 2, and 3. So when you multiply these functions, let's multiply them one by one. We get square root of 8, right? Times 0 as 0. Square root of 3 times 1 as square root of 3. Anything times 0 is 0. -1, 0. At this we get square root of 15, right? So, okay, let me write square root of 15 when you multiply, right? Okay, so that is the product of these functions, right? Now, based on these values, we can now sketch the function, correct? So, let me sketch the product first. Okay, so we'll do the sketch of product of this function on this side, let's say. Okay, so all are positive, so what I'll do here is that I'll kind of move here, okay. Okay, because we are doing from 3 towards the left side for the product, right? So what you observe here that on the right side, 1, 2, and 3, the values are 0 at 1 and 0 at 3, right? 0 at 3, let's say this is 3 for us. And it goes to almost square root 3 as the highest point at around 2, right? Maybe. That's not very critical anyway. We see that the shape of the graph is kind of like this. It starts from there and ends, right? On the other hand, -1, it is again 0, -1, and then it increases rapidly. This is rapid increase on the left side. Since when you multiply these two numbers, both are positive and increasing. So what we observe here is that on this side, the function is kind of increasing rapidly. So this is for the product of these two functions, correct? So based on this, you already know the domain of the function. The domain is the common domain, right, which is common to all these things. So we'll write down the common domain here. So the domain on which we are working for the product, let's say, is x belongs to real numbers, where x is less than equal to -1 or x is between 1 and 3, correct? So that's the domain for the function which we are considering here. We're talking about the product of function f dot g. Is it okay? And let me write down the range of this function. So range of this function is y belongs to real numbers, and you can see that y is greater than equal to 0. Perfect. That's how we can write domain and range of this function. Now how about the quotient? Let's plug in the values for the quotient, f divided by g. Now when you divide, there are these two numbers. So at 1 and -1, what do we have? We have asymptotes at these points, right? So at 1 and -1, it does not exist. Do you see that? So we have asymptotes at this point. So let me sketch this function very clearly here, right? So, and then see how it looks like, right? So what we observe here is that at 1 and -1, we have vertical asymptotes. So let me sketch the vertical asymptotes. So these asymptotes are at -1 and 1, correct? For the function which is f over g. Since g of x is 0 for 1 and -1, correct? Now we cannot have anything in between, since the domain of g of x is either greater than 1 or less than -1. Perfect. So for the other values, when you multiply, you get bigger values. 2 times square root 3, right? I mean, we have to multiply these values, sorry. F of x and g of x. So we have to multiply these values, correct? So we are multiplying these set of values, correct? So when I do 3 times 0, at 3, if I multiply at 3, 0 times 8, square root 8, I get 0. This is 0. 1 times square root 3 gives me square root 3. Add 2. Add 1 does not exist. And when you multiply these two values, okay, we are dividing, I'm sorry for that. So when you divide, 0 divided by square root of 8 is 0. 1 divided by square root of 3 is 1 over square root 3. Square root 2 divided by 0 is not defined. 2 divided by 0 is not defined. And that is square root of 5 divided by 3. It is positive, right? And a small value, correct? So based on these values, you can always sketch your graph. Now you have to remember that when you're dividing this function, we have x squared minus 1 in the denominator, right? So let me write this function here. We are doing f divided by g. So basically, we have this function square root of 3 minus x divided by square root of x squared minus 1. Now as x approaches large value on the minus infinity side, which it could, since the domain is less than minus 1, the denominator is going to be higher than the numerator, so the function approaches 0. So that becomes a horizontal asymptote. Do you see that point? So the minimum value is approaching 0 on this side, and as you approach towards minus 1, the function will be going towards positive infinity. On the right side, what we observe is that the quotient will be 0 at 3, right? At 3, it is going to be 0. But as you approach towards the 1, it's kind of increases to minus infinity, right? So at 3, it is 0. So based on this, we can write domain and range of this function, correct? So the domain will not include minus 1 and plus 1, and the range will include 0 to infinity. Do you get the idea? So let me write down the domain of range of the functions. We write domain of f divided by g will be from, we can say, minus infinity to minus 1, both not included, union from 1 not included, but 3 is included. That is important. 3 is included, right? That is filled in circle. As far as the range of this function is concerned, it is greater than 0, greater than equal to 0, since at 3 the function is 0, right? On the left side, however, there is a horizontal asymptote. With this, I think you understand how we can find the combination of functions, addition, subtraction, multiplication, and division for such a radical function or as given here, right? And I hope you understand that writing a table of values really helps to, one, sketch the graph and then write down their domain and range. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Thank you and all the best.